With this video, we'll give you an overview of virtual systems engineering and a summary of some of the newer developments in Preview, its primary product. From a high level, we're talking about modeling and simulation, and we want to do this regardless of the system in order to save time, save money, and ultimately to save lives. And this applies to any kind of scenario, whether it be electromechanical, thermal, automotive, biomedical, or anything else. We want the ability to run trade-off analyses and vary parameters and see what happens. Specifically with regards to electromechanical systems, anything with electricity running through it has a printed circuit board, so the market is very large, applications are broad, and often failure is not an option because you need very high reliability. In terms of use cases, $1 billion, anecdotally, is about what Microsoft spent on warranty costs for the Xbox because a small piece overheated because of a lack of communication with development partners. In many large companies, you can have one person work on mechanical analysis, another electrical, another data processes, another thermal, and there's very little communication in terms of file formats or in terms of software packages. We want to solve those kinds of problems. In the nuclear industry, you can have circuit cards that are 20, 30 years old, and when they fail, there can be significant repercussions. So we're interested in developing capabilities that allows us to automatically reverse engineer those circuit boards, then virtually analyze them for reliability issues, so that if there is a problem, we can see it on the computer before we see it in the real world, and then we can address those issues. The kinds of issues and the market and the problems that we want to solve are not just technical, but they're financial as well. And our hypothesis is that if we can provide a system integration software package that helps aggregate this data, aggregate these analyses, then through model-based manufacturing we can solve those problems. And we do it on 3 levels: analysis and testing, data, and visualization. That's what virtual system engineering targets, and that's what Preview does in general. Now we'll talk a little bit about capabilities for network traversal. The foundational capabilities for Preview involve visualization, manipulation of printed circuit cards in the various layers. One of the nice advantages of this is the ability to traverse networks on complex multi-level boards, and that's what you're seeing here. The ability to highlight connectivity, contact different traces, different pads, and see how they coordinated throughout various layers. Can also do what we call geometric analysis. This is essentially the comparison of MCAD, mechanical CAD, and ECAD, electrical CAD, where we automatically detect mismatches in this regard on the board level and on the pin level. And we can do this for single boards or for multi-boards as well. Here you're seeing a case where the board was misaligned with the mechanical package. We automatically find that and we allow the user to correct that issue simply by selecting a toggle. You also have the ability, a minor example here, to see network traversal between multiple boards, which is a unique capability. This is the second example where you see in the schematic the 0 point for the board is actually in a different place than the 0 point for the mechanical schematic. And it's very hard to detect this simply by looking at the drawings. However, it shows up immediately in a 3D visualization package like this using geometric analysis. Again, we automatically detect this. You can see that this offset is indicated by that white dot showing the 0 point. And we can again allow the user to correct this. We can do the same thing in terms of pin mismatch with components. We've automatically detected pins that are essentially open. They're not connected to the components. And now what you can do is leverage our underlying library, component library, find the proper component, select that component, and just within the library manipulate it, visualize it, see what that component looks like. load that into the board. It automatically gets positioned in the proper place. And again, this mismatch between ECAD, MCAD, in this case, traces, has been corrected. We'll now talk a little bit about the ability to coordinate component data. What you see here on the right is what's called an open scene graph. It gives you a verbal and structural relationship between the different components that you see in the scene. So we coordinate between the visual aspect and then the label on the right, and how that's parented to different geometric structures. Concurrently, as you select a component, whether you select it visually or select its title on the far right, on the left you'll see all the information about that component. Then, given that kind of database of data, of component information and visual models, what we can do is scrape the web, scrape manufacturing web pages to extract their information and their components that are publicly available, and we can do that on a regular basis. And here you're seeing the process you would go through to load in a new part. And this can be automated, so it happens every week, every night. And then those components are stored within our library and can be used to replace components that may not meet necessary requirements. So now, given the ability to visualize circuit cards, the ability to coordinate data, coordinate component geometry, we're going to look at new capabilities for virtual test, where, as you've seen, we're able to, for a board, create and display the schematic. And we can look at the performance of that board and plot that in various capacities, and in this example, we're not meeting a requirement. So we can go into the library, find that part that we previously scraped off the web or obtained from a manufacturer, possibly a new component, load that into the board, and then we can rerun this analysis. We can see the update to the schematic file and how things have changed, and we can see change in the part data, the part name, and then see how the performance changes. So we reloaded the components, and you'll see that the details of that schematic have changed in terms of that component characteristics. And then when we look at the performance, in this example, now we're meeting the criteria, design criteria that have been set. So that should give you an idea of the new capabilities for preview and what's going on in virtual systems engineering. Thank you.